Namaste, and a very warm welcome to our channel, my dear coding enthusiasts. Today, we are diving deep into a crucial topic for any Java developer building web applications, Spring Security Basics. In this 5-minute animated whiteboard tutorial, we will demystify how Spring Security helps you protect your applications from unauthorized access and malicious attacks. Understanding Spring Security is not just about adding a dependency, it is about building robust, secure, and production-ready applications. We will cover the fundamental concepts of authentication and authorization, explore the powerful security filter chain, and walk through practical code examples. By the end of this session, you will have a solid foundation to start securing your own Spring Boot projects. So, grab your virtual pens and let us begin this exciting journey into application security. Alright, let us start with the first core concept, authentication. Think of authentication as proving your identity. When you log into a website, you are authenticating yourself by providing a username and password. Spring Security handles this process beautifully. At its heart, Spring Security uses the UserDetails service interface to retrieve user-specific data, typically from a database or an in-memory store. This service loads a UserDetails object, which contains information like the username, password, and granted authorities. Crucially, we never store passwords in plain text. This is where the password encoder comes in. It is responsible for encoding passwords when a user registers and decoding them during the login process to verify the provided password against the stored, encoded one. A common and highly recommended implementation is CryptoPassword Encoder. Remember, strong password hashing is non-negotiable for security. Now that we know who you are through authentication, let us move on to what you can do. This is authorization. Authorization determines whether an authenticated user has permission to access a particular resource or perform a specific action. Spring Security provides various ways to implement authorization. One powerful mechanism is using annotations like @preauthorize directly on your controller methods or service methods. For example, you can specify that only users with the admin role can access a certain endpoint. The core of configuring these rules lies within the security filter chain. This is where you define how requests are handled, which paths require authentication, and what roles are necessary for specific uniform resource locators, URLs. The security filter chain is a series of filters that process incoming requests, handling everything from session management to authorization checks. It is the backbone of your application's security configuration. Let us put these concepts into practice with a simple Spring Boot example. Imagine we are building a basic RESTful application programming interface, API, where some endpoints are accessible to everyone, while others require an admin role. Here, we will configure our security filter chain to secure our application. We will define a UserDetails service that provides our user details and a password encoder for secure password handling. Then, within our security filter chain bean, we will specify that requests to API public are permitted for all, but requests to API admin require the admin role. We will also use @preauthorize, has role, admin, on our controller method to enforce this role check at the method level. This demonstrates how you can combine global uniform resource locator-based authorization with method-level security for fine-grained control. As you embark on your Spring security journey, it is easy to stumble upon a few common pitfalls. One frequent mistake is forgetting to configure a password encoder. Without it, Spring Security will complain, and your application will not start correctly. Always use a strong, modern encoder like CryptoPassword encoder. Another common error is overly broad authorization rules, for example, allowing access to too many resources with a single role, or worse, permitting all requests without proper authentication. Always follow the principle of least privilege, grant only the necessary permissions. Also, be mindful of cross-site request forgery, CSRF, protection. Spring Security enables it by default, which is excellent, but sometimes developers disable it without fully understanding the implications. Understand why it is there before you touch it. And there you have it, my friends. We have covered the essentials of Spring Security basics. We started with authentication, understanding how users prove their identity, then moved to authorization, determining what authenticated users can do. We explored the pivotal role of the user details service and password encoder and how the security filter chain orchestrates the entire security process. Remember, securing your applications is not an afterthought, it is an integral part of development. Practice these concepts, experiment with different configurations, and always strive to build secure software. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more Java programming insights. Keep coding, keep learning, and stay secure. Until next time, happy coding.